Okay, for question 1, we just need to perform these row operations, and since they're affecting different rows, row 3 and row 4, I can do each row operation one at a time. So this first one here is row 3 minus 2 times row 2. So row 3 and row 2 here, just help me keep track. So 0 minus 2 times 0 is 0. And then 2 minus 2 times 1 is 0. And then 3 minus 2 times 2, that's 3 minus 4, or sorry, negative 3 minus 4, that's negative 7. And then 0 minus 2 times negative 3, that's 0 minus negative 6. So that's 6. And then finally here, negative 1 minus 2 times negative 2, that's negative 1 minus negative 4. So negative 1 minus negative 4 is the same as negative 1 plus 4, which is 3. Now for that last row operation, it's going to be row 4 and row 2. Row 4 plus 3 times row 2. So 0 plus 0 is 0. And then negative 3 plus 3 times 1 is 0. And then here, 2 plus 3 times 2, so that's 2 plus 6, which is 8. And here, negative 1 plus 3 times negative 3, that's negative 1 plus negative 9. That's negative 10. And then here, negative 3 plus 3 times negative 2, that's negative 3 plus negative 6. Negative 9. Row 1 and row 2 are going to stay the same. Okay, well, question 2, we need to do Gaussian elimination. That's where we first create an augmented matrix. And perform row operations on this augmented matrix, and the goal is to get ones along that diagonal there, and then these 3 numbers here should be zeros, and the order it needs to go in is 1 0 0, and then 1 0, and then 1. That's the order. So we already have a 1 right there, so that number and that number there need to be zeros. So what I'm going to do to get that 2 to be a 0, I'm going to multiply row 1 by the opposite of 2, which is negative 2, and add it to row 2 to create a new row 2. So this is going to be 2 plus negative 2 times 1, so that's 0. And then negative 1 plus negative 2 times 2, so that's negative 1 plus negative 4, which is negative 5. And then 3 plus negative 1 times negative 2, so that's 3 plus 2, which is 5. And then negative 13 plus 2 times, or negative 2 times 6, that's negative 13 plus negative 12. That's negative 25. I also need to get a 0 right here, so I'm going to also multiply row 1 now by the opposite of 3, which is negative 3. Add it to row 3 to make a new row 3. So that's going to be 3 plus 1 times negative 3, which is 0. And then negative 2 plus 2 times negative 3, that's negative 2 plus negative 6, which is negative 8. And then 3 plus negative 1 times negative 3, that's 3 plus 3, which is 6. And then negative 16 plus 6 times negative 3, so that's negative 16 plus negative 18. It's negative 34. So now I want to get a 1 right here in that spot, so then I can get this one here to be a 0. So what I'm going to do is multiply all of row 2 by negative 1/5. Essentially I'm dividing everything by negative 5. So that's going to be 0 divided by negative 5, negative 5 divided by negative 5, 5 divided by negative 5, negative 25 divided by negative 5. Sorry, that became a new row 2. There we go. So let me copy that over here. So now I need to get that to be a 0. So what I'm going to do is use the 1 that I just created above it and multiply it by the opposite. So I'm going to do row 2, multiply it by 8, add that to row 3 to make a new row 3. So that's going to be 0 plus 0. That's going to be 8 plus negative 8. This is going to be negative 8 plus 6. And this is going to be 40 minus 34. And technically it's not row echelon form, but we're far enough along I can use this bottom row as the equation negative 2z equals 6, therefore z equals negative 3. Then I can take this middle row, which represents the equation y minus z equals 5. And if I already know that z is negative 3, this is y minus negative 3, which is y plus 3. So y equals 2. And now I can take this top equation, which represents, or this top row, which represents the equation x plus 2y minus z equals 6. And then I know that y equals 2 and z is negative 3. So this becomes 4 plus 3, which is 7. So x equals negative 1. So 1 comma 2 comma negative 3, or rather negative 1 comma 2 comma negative 3. And always, always, always with problems like this, check your work. If x is negative 1 and y is 2 and z is negative 3, minus negative 3 becomes plus 3, then that equals 6. Here I would get, for that middle equation, negative 2 minus 2 minus 9, which equals negative 13. And then the bottom equation would be negative 3 minus 4 minus 9, which equals negative 16. So Was there a particular part of the word problem, or just start to finish?
How do you like set it? Like I don't know, like what the. Because you know it gives us that chart, but what does the like? Does it have X, Y, and Z as a variable, or is it just the 180,
Okay.
120, and 90?
Okay, I see what you're asking. So, right here we've got 3 rows, 3 columns, so we could turn that into a simple 3 by 3 matrix to start with. Just using the numbers of boxes of whatever was sold, so 390, 590, 510. And in hindsight, I need to clarify, represent just this data here using a matrix. So,
So that's it?
yeah, just make a matrix containing the numbers. They got all the words pretty much.
That's all we have to do for that one?
For part A.
Oh my gosh. I feel like this, okay.
But then for part B, it says find another matrix. So I'm going to call this one matrix A, this one right here.
Okay.
For part B, it says find another matrix whose entries are the prices of each type of food. So there's 3 types of food. There's strawberries, avocados, and tomatoes. So we've got to make a choice, though. Since there's only 3 entries, are we going to make 1 row with 3 columns, or 3 rows with 1 column? Because the reason I'm asking is we're eventually going to have to find A times B, and A is a 3 by 3. So if I'm going to multiply this with another matrix, it's got to be 3 by something. And since there's only 3 prices, it's got to be 3 by 1, which means it's going to have 3 rows and 1 column. And each entry is just one of the prices. So strawberries were $1.80. Avocados were $1.20. And then tomatoes were 90. Just so I want to make sure, what would have been the problem if I turned this into a row?
You can't multiply it.
It'd be undefined because you couldn't multiply it.
Oh, undefined.
Yeah, you wouldn't be able to multiply it. So the way that I've set this up now makes A times B defined.
So, okay.
I'm going to call this one B. And now for part C, it just says calculate the product A times B.
Yeah, so that basically you'd be multiplying the 2 together.
And there's actually 2 parts to this one. It says calculate the product A times B, but then it says interpret the result. So if I multiply A times B, what am I going to end up with? What kind of matrix do I end up with?
3 by 1.
A 3 by 1. A 3 by 1 has 3 entries. 1, 2, 3. What do those 3 entries
X,
mean?
Y, and Z.
The
So it's the
revenue.
avocados, it's the strawberries, avocados, and
That's
the total revenue each one, each person.
Total revenue each person makes. That's what it ultimately is leading to, is how much money did John make from all of his food? How much money did Melinda make, and how much money did Josh? That's what A times B is going to tell you.
So you can't leave it ambiguous by just keeping a $sign.
They make money.
So you just multiply it and add.
Yeah. So this is definitely a calculator. Does that one make sense? I don't want to show you. It'll take a little bit of time here to multiply it all out, and you don't have to sit here and watch me do that. But from here, you guys good?
Yes, very good.
Multiplying it? Okay. Okay. Good question. So for part A times B, you always do rows first. Rows and then columns. So for matrix A, I would call this one a 3 because it has 3 rows.
Okay, yes.
But then it also has 3 columns, so it's a 3 by 3.
And then it's a 2 by 3.
but then matrix B only has 2 rows, so it's a 2, but then it has 3 columns. So you call it a 2 by 3. And since these numbers aren't the same, 8 times B doesn't work. Does that make sense?
Yes, that makes sense.
So you would say not possible.
I'm getting confused on B.
So B, matrix B is a 2 by 3, and then matrix A is a 3 by 3. So if you write it this way, now the,
Right, so you should be able to do it.
yeah. And then the answer is going to be a 2 by 3 matrix. That's what the outside numbers tell you.
So I've got that part.
So let me write this. Matrix B and then it's being multiplied by matrix A.
This is when those colors come in handy too.
Yeah.
Is the Math Center closed tomorrow too, since it's Pioneer Day?
I'd assume so.
Quick question, do we need to use the wording not possible original solution?
It's fine. I'll know what you mean. Yeah. So the answer is going to be a 2 by 3. So I've made enough space for 2 rows and 3 columns right there. And then you just have to kind of pay attention to where you are in the matrix. For example, if I want this entry right here, I've got to know that that's row 2, column 2. That entry right there is row 2, column 2. So I'm going to use row 2, column 2 to find that entry.
Okay.
Which is you multiply each of those numbers in half.
Right, and then, okay.
So that would be a 3 times negative, or that'd be 3 plus negative 6 plus 0.
What?
Oh, okay.
Okay.
Oh, I see. I'm like, what are you doing? Can you show them what you're doing? Because
Yeah, so
I can see it, but
so 3
times
and then negative 6 and then 0. So you multiply and add. So 3 times 1 and then negative 2 times 3 and then 4 times 0. And then you add that all up. And that's going to be negative 3.
Wait, so are you actually colorblind?
Yeah. For reds and greens and some shades of blue and purple too.
That's like all blue stuff.
I know. So what did I say this was? Negative 3?
Yeah. Okay, so that was 3.
That's negative 3. So the multiplication can happen anywhere. If I wanted to pop up here and do this entry,
That's row 1, column 3.
that's row 1, column 3. So I would need row 1 and column 3 for that one. So that would be 0 times negative 1, that's 0. And then 2 times 1, that's 2. And then 1 times negative 2 is negative 2. So 0 plus 2 plus negative 2 is 0. So you put a 0 right there. So it's a lot to keep track of. You really have to be mindful
That's
of
why I like the
being
circles, 'cause
careful.
The circles literally help me.
Yeah.
Okay, it's this one. Okay, not this one. Okay, not this one. And then I actually write it all the way down below so that I don't forget any of the numbers.
But when you break it down, it really is just multiplying and adding. So it's just a lot of it all together.
Okay, so like the first one's 5. Okay, I think I got this now.
The other way to set this up, and I usually do it that way. The other way to set this up is you stagger the matrices.
Yeah, this is that one you were saying.
So the first one you would write just normal 0, 2, 1, 3, negative 2. But then the second matrix, rather than writing it right next to it, the second matrix you would put up here in the top right corner. And this can help you maybe keep better track of where you are. And then your solution is going to go right here in that empty space. So the nice thing about that, I'm going to go ahead and draw lines for where the entries are. So a 2 by 3 matrix has 6 entries. If I wanted this entry, for example, it already lines up with that column and that row. The entry lines itself up with which row and column you need.
Oh, got it.
So it can help you keep a little better track of where you are and what column and row you need.
Okay.
Does that make sense?
Yeah, now I'm just wondering if I got it right.
Well, so let's check. That entry would be this row and that column. So it would be 3 plus -6 plus 0, so that's -3. This entry here would be row 1, column 1. So that's 0 plus 5, which is 5. This entry right here is row 1, column 2, so that's 0 plus 6 plus 0. This entry is row 1, column 3, so that's 0 plus 2 plus -2, which is 0. This entry right there is row 2, column 1, so that's 3 plus 0 plus 20, which is 23. And that final entry there is row 1, column 3. Sorry, row 2, column 3. So that would be -3 plus -2 plus -8. So -13. So 5, 6, 0, and 23, -3, -13.
Okay, pretty good. 5 out of 6. I love it, right? Math is true. Math is true.
And I think on number 5, one of them didn't work.
Yeah, it's B.
So remember, to add or subtract matrices, they have to be the exact same size. So if we look at matrix A and matrix C, matrix A is a 3 by 3, matrix C is a 3 by 3. So that one will work. But part B, if I wanted to add B plus A, that's not going to work.
They're not the same size.
So that one's not possible.
You just say not possible or no solution?
You know, no solution or not today or whatever.
And you don't have to show any work is implied, you just say not possible.
Yeah. Not today, maybe tomorrow.
Not today. That's cool. Yeah, so it's A for A is not possible and then not possible by B.
Yeah. Everyone is not possible.
Okay, I feel like
So
I got
3 times A would be 3, 0, 15, 3, 9, 0, -3, 3, -6, and then 2 times C is 4, 6, 2, 8, 0, 2, 12.
Mostly I just kind of missed that whole unit, but I was going.
Well, I did too, I missed this one completely, so I appreciate only understanding how to get it done.
Yeah, I never really got caught up on it.
All right, for those that have done 5A, check my math here. I'm getting 3 minus 4 is -1, -6, 17, -5, 9, -2, and then -3 minus -12. That would be -3 plus 12, which would be 9. And then 3 minus -4, 7.
It's minus -12, so.
And then -6 minus 8, -14.
Woo, we got it right.
So what if you distributed -2 and then you added?
If you distribute -2, you can do that, but then you'd have to remember to add the 2 matrices together. Yeah. So if this is your regular, if that's your beginning matrix,
Right.
then the inverse AD minus BC.
And then it's D, A.
Yep.
Okay.
Yep.
And so then with that idea. Oh, yeah, okay. I'm just good for the that.
So then for that one, you'd get 1 over this product is -10 minus, and then that product is 12. And then the 5 and -2 switch, and the 3 becomes -3, and the 4 becomes -4. Well, once you put this, so make that -12 22, so this would be 1, negative 1 over 22. And then you multiply this matrix, yeah. 5, negative 3, negative 4. And you can leave it like that.
And you can just leave it, so we don't need to do anything else. We can
No.
just do this.
If you multiply the negative 122 into the matrix, I'm not going to mark it wrong, but it's fine to leave it like that.
But if we don't do anything, if we just leave it as is, we're okay.
That's fine. Uh-huh.
For finding the determinant of a 3x3, did we only learn the minor matrix way?
No, there were two different.
All right, so your matrix equation would be a matrix with just the coefficients, like that. And then you have a matrix with your variables. And then one more matrix like that. So what we're trying to solve for is that matrix right there. We want to figure out what x and y equal. So if we wanted to represent these using symbols, we could call that one matrix A, that one matrix X, and this one matrix B. So we essentially need to cancel matrix A so we can get this matrix here all by itself. And the only way to cancel a matrix is to multiply it with its inverse. So we got to find the inverse of matrix A. And once we do that, since it's an equation, we have to multiply that inverse on both sides. We have to multiply by the inverse of A over there also. So there's two things. First thing we got to find is the inverse of A. So matrix A was just this, that matrix there. There aren't many formulas in chapter 6 you got to remember, but this is one of them. If we have a matrix A, B, C, D, do you remember what the formula was? So it's so you switch D and A, so negative B, negative C. Yeah, so you got to use that formula for matrix A to find the inverse. So 1 over A times D, that's going to be negative 8 minus, and then B times C is negative 9. So it's just 1. And then these two numbers there switch places, so negative 2, 4. And these two numbers here just change signs, so negative 3, positive 3. Yeah, and that negative 8 plus 9, that's just 1, so it's 1 over 1. Usually, though, that turns out to stay a fraction, so you want to keep that fraction. Rather than multiplying it in, you just want to keep that fraction out front. 9 times out of 10, that doesn't turn out to be a nice number like 1. So yeah, so then we take this matrix, this inverse, and we multiply it by that.
Okay, but
I think it's not possible. But
Yeah.
like no solution.
So x equals A inverse times B. So A inverse times B so this entry is row 1, column 1, so that's going to be negative 20 plus 90. So that's 70. And this entry is row 2, so it's negative 30 plus 120.
Okay.
90, yeah.
Is that the answer?
Well, let's see. Let's check it. So 4 times 70 is 280. And 3 times 90 is 270. So 280 minus 270 is 10. So that one checks out. 3 times 70 is 210. 2 times 90 is 180. 210 minus 180 is 30. So one final step, though, is instead of leaving your answers in a matrix, we're trying to find out what x and y equals. So it's got to be an ordered pair. So 70, comma 90, and this is what you would circle here for full points.
Okay.
Oh, yeah.
I remember drawing a picture going, this is number 8.
So the expectation would be if this were a question on the final exam, right? Because I know it's easy just to jump into this and multiply it by this matrix here, but what the rubric would say is to set up your matrix equations first. So you would have
So on the math file, you want us to do this?
you would have your matrix of coefficients,
Write it out. That's just how I've always done my whole life.
and then show that you know that you're supposed to multiply it by an inverse.
Right.
And then you have a matrix of variables, and then a matrix like this. So these are your matrix equations, or your matrix equation.
I know we did this one yesterday.
And from here it's fine if you represent the rest of it symbolically, so labeling the matrices like that, and then showing that, hey, if I want to cancel matrix A, I need to multiply it by the inverse, and multiply that by the inverse. So this is what we're trying to find, is the inverse of A times B. So this is what we're trying to find, that inverse matrix multiplied by -6, -3, 6. So I always want to double check just to make sure it'll even work. Matrix A inverse is a 3 by 3, and this one is a 3 by 1. So it'll work because the inside numbers match. And it'll give you a 3 by 1 matrix. Now you were saying you use colored pens. What do you do for that?
So what I do, so for example, so like this number would be a color, and then all of these in this row would be that same color.
So if you say I want this number here,
Then,
oop,
and that number, then like,
would you circle that entire row and that?
no.
Like
No.
that?
No. It's the other way. You don't circle them, I circle them individually, that's what she showed me. And
Oh.
it works beautifully. So that way you know that this one times this one plus, and then this one is a different color.
Oh, okay, I
This
got you.
whole row is different. They're each circled individually so that you know you're not multiplying all those together. You're individually multiplying it to that one,
Oh.
and adding it, and then you multiply that one too.
So like this number and that number would be a color.
Exactly.
And then-
also this down this row would be the same color as that one.
Whoops. Come
I'll show
on.
you.
Different color. There we go. And then this one and that one.
It's struggling.
It's struggling. There it is.
Yeah, but that whole column would be circled with green, but individual green. So 1, 2, and 3 would be circled.
Oh.
Like this. So this one multiplies with that one and then adds it to this one times that one plus this one times that one gets you your number. And then this one times that one.
Well, this is where it
Times
sucks
that
to be
one.
colorblind because that all looks like the same color to me.
Does it really?
Yeah.
Colorblind?
That all looks like the same color.
That's green and that's blue and that's purple.
Huh.
So because you're doing row 1, column 1, right?
Yeah.
So because you're doing row 1, that's all going to be
It's like, what color
So
is
the
this?
row
It's like my
one.
older brother, but like 6 years.
So row
I
one,
like can barely talk.
column one, and this is row one, column two, row one, column three.
Okay.
And then that helped me to see the colors and be able to understand
Well, that's nice.
the difference. And it
Helps
made
us
a
stay
huge
organized.
difference. In fact, I actually helped Hattie figure it out based off of that too.
Cool.
So we spread the
I
love.
couldn't get it.
But you weren't quite getting it. So
I know, it's too much, like, for
Okay.
me. My,
Well, this entry right here is row one,
that's how
column
I got it.
one.
Right.
So that would be -1 times that's 6 plus 9. So that's 15, and then plus -30. So it should be -15. And then that middle entry is row 2, column 1. So that should be -12, -12. -12, -12. I'm getting a 0 for that middle one.
Yeah, I got that.
-15, 0. And then that last one is row 3, column 1. So that would be -12 minus 9, that's -21. Plus 12, that's -9.
Is that a 0?
Yeah, zero.
So the answer should be -15, comma 0, comma -9. And what do we do once we think we have an answer?
You check it on all three
Check,
equations.
check your answers. Yeah. So -15 times -2, that's 30. Plus 0, minus 36, that's -6.
Not the math, trust yourself.
No,
You
I
trust
trust-
yourself.
I trust the math.
-30 plus 0 plus 27, that's -3.
One wins.
And then 15 plus 0 minus 9 is 6.
And it works.
It works.
I'm done with the diagonals.
You like the diagonal way?
Yeah.
Okay. So, well, let's do A real quick. 2 by 2 is that product, so that's -4, minus that product, which is +6. So I'm getting -10 there. The diagonal method for a 3 by 3, you're going to take this first column, 2, 3, 4, and duplicate it. And same with that middle column, 1, -7, -6.
Right.
So you write those first two columns there on the right side of the matrix. Then you always start from the top left and go to the right, and those ones you add. So this product, oops, and then you add this product, and then you add that product. So you got to find all three of those products and add them together.
Okay,
And
so
that's
you
the diagonal
multiply
method.
them and then you add.
So that direction, when you're going top left to bottom right, those three products you add together. So 2 times -7 times 0, that's 0. And then 1 times 0 times 4 is another 0. And then -5 times 3, that's -15. -15 times 6, that's 90. So -15 times -6 is 90. Somebody better double check me on that one. I believe it's 90, and believing is really what it counts in.
Oh, we were supposed to do that, sorry.
Now, the next three products are going the other direction, so you start, so you find that product, this product, and that product, and you subtract all of those. So 1 times 3 times 0 is 0, and then -5, let's see, 2 times 0 times -6 is 0. And -5 times -7 is 35, times 4, that's 7, that's 140.
Yeah.
So then you combine all of that.
So 90 minus 100. Nice. Okay.
Yeah, can you do this one more time, a little slower?
The diagonal method?
Yeah.
Yeah. So let's try this one more time. Let me erase.
What's the traditional way?
I'll do that one. I'll do that one also, so you can see.
Okay.
So this method of diagonals, you take this first column here and write it on the right side,
Right.
and then you take that middle column, do the same thing, and then you start in the top left and move diagonally. So you do these three products. Product means multiply. So you take each time I've drawn a line through three numbers, you multiply all those three numbers together and add them.
Okay.
So the 2 -7 times 0, that's where the 0 came from. And then the 1 times 0 times 4, that's where that 0 came from.
Right.
And then the -5 times 3, that's -15. And -15 times -6 is +90.
Okay.
The important thing to remember there is when you're going in this direction from left to right, you always add.
Because you're going positive.
Whoop, come back. There it is. Does that make sense in that direction?
Right. And then right to left is subtract.
And then you find the other three products. So now you go this direction. So the 4 times -7 times -5, it's positive 140, but since I'm going from right to left in that direction, I subtracted it. So subtract 140. And then the 2 times 0 times -6, that's -0. And then 1 times 3 times 0 is another 0.
And you're always subtracting the sum of that with that.
Yep.
others.
Cool.
So you get -50.
So if the 140 was a negative 140, and then you subtract the negative, so it would be a plus 140, would it be 90 plus 140?
Correct.
Yes.
Yep. Now the other way of doing it, for those that are interested, can I erase this?
Yes.
The method of minors.
Yes, the method of minors.
So I would choose a row or a column that at least has 1 0. The nice thing about this one, it has a column with 2 zeros in it. So if we expanded down that column, the method of minors would actually be really quick on this one. So I'm going to take the -5 and then cross out the row and column, and that would leave
That gives you the
a smaller 2 by 2 matrix. 3 -7, 4 -6. Oops, where am I going? So 3 -7, 4 -6, and then you technically you do the same thing. You go down the row. So you would, if you remember the pattern.
Okay, you have to remember that pattern.
So technically you would subtract, and then you move to the next number, subtract 0. But 0 times the determinant of any matrix
It's gonna be 0.
is 0. And then you move down to the last entry, and then you're supposed to add that. But 0 times the determinant of that matrix. So
0. So what it's whatever that inside is times the -5.
so it's -5 times that determinant, which is -18 minus -28. That's terribly written.
It's 10.
Let me give myself some more room. So this is a determinant right here. It's just the determinant of a 2 by 2 matrix. So it's that product, which is -18, minus that product, which is -28. But that's plus 28. And -18 plus 28
It's 10.
is 10. So this is -5 times 10, which is -50.
As long as you get the same answer, you're okay either way.
Yeah, yeah. Either way works, and it doesn't really matter which row or column.
That's right. It doesn't matter where you start on the column.
The determinant for that matrix is going to be -50 no matter which way you do it, and no matter which row or which column.
Bless you.
So-
Can we have a problem like that where it's only just 0 and we can do the next method that's a lot less complicated than the other one?
Well, you can do it either way.
Possibility.
And if you want, we can go over it, but it's not.
You can do the method of minors like this. So this method is called the method of minors, or you can do this one where you take the other two columns, and the method of diagonals is what it's called. So you're going to do three determinants, but each of these determinants is only going to be a 2x2 matrix.
Right, because you've just got you've got two,
Yeah, so for this first one, D, you just make a matrix containing just the coefficients there.
boom. And then you use that formula thing.
Yeah, so then for a 2x2, it's a real quick, this product there, which is 12, minus that product there, which is negative 10.
You're looking at 22.
You see what I'm saying? Yeah, and then from there, so then D sub x, if you look at the subscript, now this x column here would be replaced with
-1 and
that column, so -1, -31. But then the y column stays the same. So we do the same formula. So this product there is -4 minus that product is
6.
positive.
It'll be -10.
Well, that's a
Oh,
31.
sorry. Oh,
Yeah.
31, sorry, I missed that, yeah, positive. Wait, wouldn't it be positive 62?
It is, but you minus
oh,
it.
right. I see
Yeah.
what you're saying, yeah. Uh-huh.
So
And
that's
negative
-66. And then now this determinant is going to have the -1 and the -31 in the y column. X column stays the same. So this product is -93 minus that product, which is -5.
They're row operations. It'll be, so just do this.
-88.
And then you take, for D sub x, you would take -66 divided by 22.
Right. So then x is your D sub x value divided by D, which is -66 over 22, which is -3.
And then y is -8.
D sub y for D, which is -88 over 22.
Equals -4. So then your answer would be -3, -4.
The best piece of advice I can give you guys on this exam is check your answers. Check your answers. So if we check -3, -4, 3 times -3 is -9, -2 times -4 is +8, and that equals -1. And then 5 times -3 is -15, 4 times -4 is -16,
Yeah, it gives -31. Nice.
and that
Check
equals
that one.
-31.
That's awesome.
So.
Cool. So then we'll come back